Hello students, welcome to TSS Tutorial Center, where we make complicated topics simple, simpler, simplest, and interesting to understand. So if you're in G12, you're in grade 11, you are in grade 10, and you've been having challenges, then make sure you do subscribe to this channel, because we're going to make you become better, become very good at what you do, and make sure we show you that getting a distinction is very easy than failing. In this tutorial, we talk about limiting reagents. Very interesting. It's very much important that you understand limiting reagents. A reagent is just a reactant. It's important because you're going to be talking about percentage yield, and if you don't understand limiting reagent, you're going to find that percentage yield becomes difficult for you, but it's very simple. So make sure you understand limiting reagents. Okay, suppose you're coming back from school after eating a lot of popcorns. You go home, home sweet home, and some of you are already married, so you just find they have cooked for you, and this is the dish. Bam! So let's say apa, but each word, each word you got about 20 lamps. And so but if you come on now, sausage come. When you start eating, then after, let's say, 10 minutes, after 10 minutes, you realize that there is no relish is done. But looking at the plate from Shema, there is Shema still there on the plate. But you stop eating. You stop eating. Now, I want you to think of eating as a reaction. And how full you're going to be as the products. So this means how full you're going to be is dependent on the limiting reagent. When the relish is done, no reaction, you stop eating, and there will be nothing like as in you go back and ask for more food. No, just think of it as when the relish is done, no eating, no reaction, it is done. How full you're going to be is going to be depending on the limiting reactant. This definitely means that when finding the number of moles and the mass of the products, we are not going to be using this guy which is in X's. We're going to be using the one which is a limiting reagent or reactant. This is simply because we are saying how full you are going to be is dependent on the how much limiting reagents do you have. This is the point I want you to keep in mind. Whenever you face a question about limiting reagents, first of all, think of it in this way. Now, how do we find the limiting reagent? But from what we have talked about, I can ask you a question to say, what is a limiting reagent? Okay, so I want you to get my point. This is a reactant which is in short supply by the mole ratio, and hence it finishes first during the reaction. This is a reactant which is in short supply by the mole ratio, and it finishes first before other reactants are completely reacted. Now, we're not saying it is in short supply by the number of moles. Keep this in mind. We are saying short supply by the mole ratio. Now, for example, you have a reaction A plus B producing C and D. Now we balance and we find that these guys, they are the coefficients of the balanced chemical equation. When talking about limiting reagents, we just focused on the reactants. So this side, when you're trying to determine the limiting reagents, you don't use the product. You're going to be using the reactants. So you're going to compare this one and this one. So suppose you have Na as the number of moles of A and NB as the number of moles of B. Now, when this number is less and this one is greater, then you start saying that, oh, since A is less and B is greater, then B is the limiting reagent. No, these are the number of moles. And we said not the number of moles, but the mole ratio. So what are you going to do to find the mole ratio? What you do is very simple. You're going to do this. So you're going to say mole ratio. Then you're going to get the number of moles of A and divide it by its coefficient from the balanced chemical equation. And again, you get the number of moles of B divided by the coefficient from the balanced chemical equation. Then compare what you're going to get. The number which is going to be smaller, that is the number which is representing the limiting reagent. Okay, so I bet you have gotten my point. Now let's try to put this in practice. Let's solve some questions. Okay, so these are the questions that we have. First of all, let's do this, then we'll move on to the next questions. I want you to follow me very well. The questions are simple, just follow the concept. Solutions. Start with the first one. Number 1. Okay, so the question is saying 19.5 grams of zinc and 9.4 grams of sulfur were heated together. This is the reaction that we have. The first question, A, which of the two is a limiting reactant? Okay, so take a look at this. We've been given the grams, but not the number of moles. We've been given the grams of zinc, that is 19.5 grams. That of sulfur, 9.40. Okay, now what are we supposed to do here? You don't compare the grams, you compare the mole ratio. For you to compare the mole ratio, you're supposed to find the number of moles. Using the formula we talked about, number of moles is given by what? Mass over what? Molar mass. So I'm going to find the molar mass of zinc. Let's just check on your periodic table, it's already there. So the molar mass of zinc is going to be 65. And when we divide, what are we going to get? We get 0.3 number of water moles. Then what about sulfur? We'll do the same thing. So we have 9.4 divided by, when you check on the timetable, on the periodic table, sorry, it's supposed to be 32. That is the molar mass of sulfur. Now when we divide these two numbers, you should get 9.4 divided by 32. You should get 0.29. Don't round off. 0.700. This is what you should get. Now, look, this is 0.3. This reaction, we have managed to find the number of moles. Now, what is the mole ratio? What are we supposed to do to find the mole ratio? We said we're supposed to divide by the coefficient from a balanced chemical equation. So this is the equation that we have. The question is it balanced or not balanced? Zinc 1, this side it is 1, sulfur 1, sulfur this side 1. So the coefficient, they're just 1. Even this 1. When we divide, we're going to have the mole ratio, which is zinc, then this side sulfur, 1 divided by 0.3. I mean 0.3 divided by 1, that is 0.3. Again, 1 divided into this number will just give us 0.29. 375,700. Now, between these two numbers, which one is more? This is the more ratio. This is the more ratio. But if you're not doing this, you start forgetting. You'll be thinking what you're doing is correct, but it is totally wrong. So make sure you focus on it. You divide by the coefficient from the balanced chemical equation. Okay, so we can tell that this number is small, so the limiting is therefore sulfur. We're done. We have managed to find the limiting reagent. So sulfur, since it is the limiting reagent, is the one which is going to be telling us of how much products we're going to have. The next question B, it's telling us to find how many moles of zinc remain unreacted. Very simple. Let's do it from here. B, you've managed to find the number of moles of zinc, this much, and that of sulfur, this much. So what are you going to do? You're just going to subtract. That is the number of moles of zinc that will remain will be equal to 0.3 minus 0.29. When you do so, you should get 0.01 moles. Now, a mistake that you can make, they can also ask you, like, that is example C. How many grams of zinc element remain unreacted? So some people think what they're going to do is they will get this guy minus this guy. That is totally wrong. You don't use the masses. Now, you're going to use the number of moles that remains unreacted. Then you find the mass. What am I talking about? What I'm talking about is this. We have the number of moles of zinc which remained unreacted, that is 0.01 moles. You're going to use the number of moles to find the grams which remain unreacted. Instead of using the mass, you get this one minus this one. It's going to give you a wrong answer. So what we're going to use is this guy. So it's going to be number of moles again is equal to mass over molar mass. So you are finding the mass, making it a subject, that is number of moles multiplied by the molar mass. So substituting 0.01 times the molar mass. What are you going to get? Let's see. What is the molar mass of zinc? It is 65. So when you do your multiplication here, you should get 0.65 grams. You are done. Very simple. Just make sure you follow the concept. Okay, so far so good. Let's see the next question that we have. Before we go to the next question, if the question, this one, the one we are from doing, it asked us to find the number of moles of zinc sulfide. What are you going to use between sulfur and zinc? What are you going to be using? You're going to be using the limiting reagent. Never forget, even when it comes to percentage held, that is a simple concept you're going to be using. So keep in mind, we use the limiting reagent. Let's look at number 2. Okay, so the question is saying, how many grams of hydrochloride could be produced from 0.49 grams of hydrogen and 50 grams of chlorine? And this is the reaction that we have. We can see that it's already balanced. Hydrogen 2, this side 2 as well. Chlorine 2, even this side 2. This 2 implies that it's on hydrogen, it's also on chlorine. Okay, so the question is telling us to find the grams of hydrogen chloride, which is the product. Now, since it is the product, how full you're going to fill. It's going to be dependent on how much limiting reagent do you have. So in this question, you're supposed to find the limiting reagent. Okay, now what are we going to do? Finding the limiting reactant. We've been given the grams of hydrogen and the grams of chlorine. Do we use grams? Definitely no. We use number of moles. So let's use the number of moles. What are we going to do? We know that number of moles is given by mass over molar mass. I was thinking it's only in grade 12 I'm going to be using this formula, but even when you go do the programs that you're going to be doing, number of moles is equal to mass over molar mass. It will be a song that you'll be talking about. Okay, so that of hydrogen. Hydrogen exists as a diatomic molecule, so you're supposed to put 2 here. So we're going to have the grams 0.49 divided by the what? Molar mass. And in this case, it's going to be 2 times 1. So when we do the calculations, what are we going to get here? We should get 0.245 number of water moles. You go on for chlorine, you do the same thing. Even chlorine, it exists as a diatomic molecule. You're supposed to put a 2 there. You can keep in mind the group has 7 elements. They exist as a diatomic molecule. Oxygen as well, hydrogen, and nitrogen. Okay, so what are we going to do here? 50 divided by 2 times the atomic mass of chlorine. So if you have forgotten how to find the molar mass, we're just counting how many atoms do we have. 2 or times the atomic mass, bam. So for hydrogen, the atomic mass is 85.5. When you multiply here, you should definitely get 71. And when you divide, you should get 0.704 moles. Now, we have managed to find the what? The number of moles. So what are we going to find next? The mole ratio. So even if I have ones, I always find the mole ratio so that I don't forget. I will never forget. So some of you will be just like, since it's just 1, okay, when I divide 1, it's just, just do it. Even if you know that's going to give you the same thing. Chlorine this side. So you start dividing by the number of coefficient. So the coefficient of hydrogen is 1. Divide it into this number, you end up with the same number. Oh, what about this one? Still, the coefficient is 1. Divided into that number, you still get the same number. So between this one and this one, which one is greater? This one is less, this one is greater, not so. So the one which is less is the limiting reagent. So we can say, therefore, the limiting reactant is hydrogen. By doing so, you are done. You are done. You have determined the limiting reagent. Now you can find the grams of hydrogen chloride. Okay, so now to find the mass of hydrogen chloride, what are you going to do? Remember what we talked about. From the balanced chemical equation, you're going to obtain what is known as the mole ratio, which is the coefficient of what you have, the chemicals you have. So for hydrogen, the coefficient is 1, and for this one, chlorine is also 1, which is this one. Then the last one, it is 2, the number that you're seeing in front. So this is the mole ratio that we have, the mole ratio. Now, how do we use the mole ratio? We use the mole ratio to find the number of moles. So I'm going to find the number of moles of hydrogen chloride, then use it to find the mass. Very simple. So what are we going to do? Look, how many grams? But we are finding the moles at first. How many moles of hydrogen chloride? So you're going to go back to the equation and ask yourself, what is the mole ratio of hydrogen chloride? It is 2. So we are going to say 2 is equal to X moles. First find the moles. Then what have you been given? You use the limiting reagent, and we know it's hydrogen. So you go back to the equation. Where is hydrogen? This one. What is the number in front? 1. What is the number of moles of hydrogen? Is 0.245 moles. Then what are you going to do next? So cross multiply. You're going to have X into 2 times 0.245. 2 times 0.245. Match this on your calculator, see what we're going. So you should get 0.49. Now this is the number of moles. But then you can even use it to find the mass. When I'm using this formula, I don't get these questions wrong. I would be just breaking it down step by step. It feels long, but when you know it, you'll be enjoying. And a lot of people use this procedure. So we are finding the mass, that is number of moles multiplied by the molar mass. So what are we going to have? The number of moles is 0.49 times the molar mass of this guy. Now you don't get the coefficient from the balanced chemical equation. You are finding the molar mass of hydrogen chloride. So hydrogen chloride, it doesn't have a 2. This is just because it was being balanced. So the molar mass just going to be for this guy. And in this case, it's going to be, you have 1 hydrogen times 1, that is its atomic mass. From the periodic table, how many chlorine do we have? 1 times 85.5, which is from the periodic table as well. So when you multiply this, what you should get is 17.885 grams. Please know the steps. Know the steps. Let's try another example. So this is the next sweet example that we have. Question 3. How many moles of iron trioxide can be produced by reacting 16.8 grams of iron with 10 grams of steam, that is H2O, in form of a gas? So we've been given the equation and it's already balanced. These questions, you'll be given equations and they are already balanced. So just answer. Okay, what are we supposed to do here? Understand the question. How many moles of iron trioxide? This guy. The product. Now you can't find the number of moles of the product minus knowing which one between iron and H2O is a limiting reagent. So this one is even more interesting. What are we supposed to do? Find the limiting reagent. This is very simple. Solutions. Okay, so look at this. We have iron and H2O. You're going to find the number of moles of both reactants. So for iron, you're going to see 16.8 divided by the molar mass, which is just on the periodic table, and it is 56. Look, there was someone who was making a mistake. When finding the molar mass, you were including 3. No, you don't include anything from the procedures and how you were balancing it. No, these numbers, you don't include them when you're finding the molar mass. You don't include them in capital letters. Don't ever forget that. If you're watching this tutorial and you know I'm talking about you, please don't make the same mistake you made. I'm quite boss. So when you divide, you should get 0.3 moles. What else? You go for H2O. The number of the grams is 10 divided by the molar mass of H2O. I'm not including this 4. Nah, just taking the H2O the way it is. So you have 2 hydrogen times the atomic mass, just 1, plus how many oxygen do you have? 1 multiplied by the atomic mass, 16. Okay, so we're going to have 10 divided by 18. When you do the calculation, you should get 0.55556. Now, what are we supposed to do here? We've managed to find the number of moles of water hinged ion. From there, we said you're supposed to get now the mole ratio. You're supposed to find out the mole ratio. How do you do so? Very simple. Just get the coefficient of the reactant and divide it into the number of moles that you have. So you're going to say 0.3 divided by 4. This is for ion to that of H2O. What is the number of moles of H2O? 0.5556 divided by the coefficient on the balanced chemical equation, 4. Oh, I made a mistake here. It's supposed to be 3. But when you divide, this side you're going to have 0.1. What about this side? 0.138, which is just 0.4. Now between this one and this one, which one do you think is greater? It is what? This guy is greater, this one is small. Okay, so iron is the limiting reagent. Now, if you're using your common sense, and we look at the grams of iron, it is even greater than of H2O. But at the end, we are finding that the one which is having maximum grams, it is the limiting reagent. So don't use the common sense, use the calculations. Even here, at this point, okay, it's making sense somehow. This is bigger than this one. Okay, so we have determined that the limiting reagent is iron. What are we supposed to do next? Calculate what we've been told. So we're going to use iron to find the number of moles of iron trioxide using the same procedure that I told you about. So it's going to be the mole ratio obtained 3 to 4. The coefficient of iron trioxide, the number in front is just 1. Then hydrogen is 4. This is the mole ratio. Then what are you going to do? Go back to the question. How many moles of iron trioxide? Okay, ask yourself, what is the mole ratio or the coefficient of iron trioxide? 1. Have you been given the number of moles? Definitely no, so put X. Go back again. What have you been given? We're using the limiting reagent, which is iron. So you go back to the equation. What is the coefficient of iron? 3. What is the number of moles of iron? So you don't use the mole ratio. You don't use these guys. You use the number of moles that you calculated here. That is 0.3. Then you do the cross multiplication. you're going to have 3x is equal to 0.3. When you divide this side, you're going to have x being equal to what? 0.1 number of moles. So if you were told to find the mass, you could have just used number of moles is equal to mass over molar mass. Then you use the number of moles that you have found here to calculate the mass. Now, a question that a lot of students ask is, sir, what if when you're dividing by the coefficients, you have managed to find the number of moles. Then when you divide by their coefficient from the balanced chemical equation, you end up getting the same thing. Like this number is equal to this number. What does that mean? It means you have two limiting reagents and you can use any to find the products. It's going to give you the same answer. Let's say the next question that we have. Okay, so this one, I'm sure you can answer this question. What is the mass of water that is going to be produced? This is the data that you've been given. You have 8.0 grams of hydrogen and 0.8 grams of oxygen. The grams, they don't determine which one is the limiting reagent on the mole ratio. So you can say since this one and this one, they are equal, so there is no limiting reagent, or they are both limiting reagents, and you're not going to do any calculations. No, it doesn't work like that. You're going to find the number of moles of hydrogen. So this one, I'll tell you how to go about it. Then try to do it on your own. First of all, find the number of moles of hydrogen. And take note, hydrogen and oxygen, they exist as a diatomic molecule. So it's supposed to be put in 2, 2, 2, 2. When you find the number of moles, divide by their coefficient from the balanced chemical equation. The number which is going to be small, then that is the one which is representing the limiting reactant. Use the limiting reactants to calculate the number of moles of water. When you find the number of moles of water, then use number of moles is equal to mass over molar mass. Do the cross multiplication, then the number of moles that you found multiply times a molar mass. Then you have managed to find the mass. Very simple. So I want you to be picturing from that way. The bar followed by Bantu bar Monaco bar promoter. Thank you for watching.
I'm obsessed, I am so in love with myself. I dey bust my own brain.